Hello again. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, your host. It's great to have your company. And on this episode, we're going to take another look at 3I Atlas. And it's not a positive story, and we'll explain why. And it correlates with another yarn we're going to have about the US government shutdown and the impact that that is having on all things space-related at the moment. There's also a very controversial story, and the two sides in this are certainly not on the same page, and that is sending human remains to Mars. And new evidence of the formation of the moon, and we're going to have a quick chat about the potential for, wait for it, a Gnab Gib. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to unpackage all of that is Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Hi, Jonti.
Morning. How are you going?
I am very well. And you?
I can't complain too much. I'd have been better if football results had been different. But, you know, it's a new week. Mondays are always terrible anyway, so that was just added salt in the wounds.
There was an Australian band who once recorded a song called Monday's Expert, and it was all about what you'd talked about on Monday after the sport was finished on the weekend. It's a very clever song. We should get straight into it because there is so much to talk about today. And this first one is 3I Atlas. Now, we've talked about it a couple of times, but this angle on the story is a bit of a downer because we talked about how there would be great observations of 3I Atlas from Mars, and that data was really going to be exciting and being looked forward to. It has not been released, and for a very unfortunate reason.
Yeah, this is the ongoing story of the thing that is definitely not aliens, basically. Mm-hmm. Now, it should be said straight away that Comet 3I Atlas came quite close to Mars, not perilously close by any means. There was never a risk of a collision. Whilst it was in hiding, it was on the far side of the sun from us, lost in the daylight sky. And so in order to track it through its perihelion passage, people have been very keen to keep an eye on it using spacecraft at Mars. Now, we have got images back from European spacecraft and from the Chinese Tianwen mission, but NASA have been notably silent. Now, Avi Loeb, who is continually pushing the narrative of aliens, and a Republican representative in the US called Anna Paulina Luna are crying foul. They're kicking up a fuss to try and keep the alien narrative in play, I think, as much as anything else, saying, it's disgraceful that NASA have been so quiet. They should be releasing the images. What are they not telling us? NASA, come on, release the images now. And I'm paraphrasing a little bit there. But They're kicking up a fuss about the fact that, you know, NASA haven't released anything and the comet was closest to Mars on the 3rd of October. These spacecraft have gathered all the data. Why are they not releasing the images? There must be something that's hidden. Ignoring the fact, of course, Europeans and the Chinese are releasing images. Mm-hmm. What really infuriates me about this, to be honest, is that there is a very good reason that NASA has not released anything. It's the same reason that the wonderful Astronomy Picture of the Day website that I check most days has not updated since the start of October. There is a US government shutdown happening at the minute. NASA staff are considered non-essential, which means more than 15,000 of them are furloughed. They are not getting paid. They're not allowed to work. But beyond that, if they do anything that looks like they're working in their professional capacity, they run the risk of being sacked.
Gosh.
Straight up. And I've got colleagues in the US who are suffering from this, you know, collaborators of ours on our Planet Search program. They sat at home twiddling their thumbs, wondering where the next meal's coming from, living off the earnings of their partners if they have partners. And they cannot do anything. They can't get this data. They can't comment on it. Now, you know, you could give Avi Loeb a little bit of benefit of the doubt. I'm a bit loath to do that, but maybe he hasn't twigged that there's a government shutdown happening in the country that he's in that's affecting his colleagues in his department at Harvard. He may not have noticed, you know. I mean, he's been that busy telling everyone it's aliens. Perhaps he's not talking to his colleagues, or perhaps they're not talking to him. But for a US Republican representative who sits in the House, who is part of the reason that there is a shutdown, to be spinning essentially lies for political gain you've got to assume that she knows that NASA can't talk about this because she understands the shutdown's on, right? They're causing this.
Yeah.
The only thing I can assume here is that she is convinced that her voter base are anti-science, and therefore it's easy points to score. And it's like kicking somebody while they're down.
Yeah.
It's really not on, and there is no story here. NASA are not talking about the comet because nobody's there. The phones are on the hook, nobody's in the office. It isn't anything to do with aliens. It isn't that there's anything untoward or dodgy going on. And added evidence for that is the fact that the other space agencies have released images. They've released their data. We've also got now 3i atlases starting to get far enough away from the sun that people on Earth are starting to get some nice images again. Saw a lovely one on Facebook in the Comets group this morning showing beautiful structure in the tail of Comet Atlas and things like this. So the information's there. They're just cherry-picking that NASA are quiet to try and push this false narrative, and it's just getting tiresome, to be honest. But it's very offensive in terms of the situation that the staff at NASA are under, that people can come out with such hokey.
They're between a rock and a hard place because they can't talk about it because they've been, to use the Australian vernacular, laid off. Mm-hmm. They're not getting paid. If they do say something, they're in breach and could lose their jobs. I mean, so they're having to listen to this rubbish that's coming out about them, and all they can do is sit on their hands. I think it's horrendous, and I can't imagine this happening in Australia. There's no way that any government in Australian history would get away with this. If the current government shut down all the government departments and stopped paying people, there'd be rebellion.
Well, not just that. I was under the impression that the US prided itself on its commitment to free speech. Mm. And yet you're not allowed to do any work and you can't speak to anybody because we're having a fallout in the Congress. That doesn't speak to free speech for me. The idea that if you raise your hand and counter this absolutely cobbler's narrative that's coming out, you'll lose your job. How bizarre is that? I mean, that's like something from some kind of movie, like 1984 or something.
Yeah, that's exactly what it's like. Yes. You can be put to death because you gave somebody a check.
Yeah, it sounds hyperbolic, but it stretches beyond NASA. We're aware of it from NASA from the point of view of this podcast, but all the government agencies are into that, which will lead us into the second item shortly. But it's a bizarre situation, and I'm not in the US, I'm not in the nitty-gritty of it, I'm certainly not involved in the politics of what's going on, but it makes your head hurt that the most successful space agency on the planet with all these fabulous missions can't do anything. And it may well be that some spacecraft will be irrevocably lost because of this. There were discussions about Juno around Jupiter, the fact that its funding ended just before this, so they couldn't even have somebody on tick over for it because the funding had ended. So nobody can do anything to put it into maintenance mode. What odds that when the shutdown finally finishes, Juno is incommunicado forever?
Yeah. And that's a terrible waste of hardware and money, really.
Dollars down the drain.
Yeah, absolutely. Let's move on to that next story because it does correlate exactly with what we've been talking about, the US government shutdown and how it's affecting flights, but it's also affecting domestic airline flights, but it's also affecting rocket launches, and that is going to have an impact on a couple of big missions that are planned.
It is. So I saw this actually on the BBC website on yesterday morning, as we're recording this, that the big article there was more than 1,400 flights cancelled in the past 24 hours because air traffic control is effectively on a go slow in the US at the minute. Now, that is kind of understandable because the air traffic control people, guess what? They're government employees and there's a shutdown. Yep. I mean, who'd have thought it? And it's been exacerbated because I think there was a very high-profile aircraft crash last week. So there's been a lot of air issues in the news anyway. I was just checking updates on that. That's why I was looking over to the other screen there. But basically, what's been happening is to deal with the ongoing shutdown, the FAA, which is the Federal Aviation Administration, is bringing in increased restrictions on who can use airspace at what time to try and lighten the load on the people who remain in the air traffic control stuff, to keep it manageable. And this is entirely responsible, it should be said. If I'm on a plane coming into land at an airport, I want air traffic control to be on top of what's going on. And if they've got fewer people there, it makes sense to lighten the load so that they can manage things and so you don't run into catastrophes. Totally, totally reasonable. Where it impacts us from a space point of view is that starting today, Monday the 10th US time, so for us here in Australia, that's late tonight, there is a new restriction coming in as part of this airspace management thing, where any commercial rocket launches will be limited to only occur between the hours of 10 p.m. EST and 6 a.m. EST. So that's an 8-hour window every day in the middle of the night when airspace is quietest, basically. Now, that's going to have a little bit of an impact on the research side of things, and I'll come to that in a minute. The main impact will probably be on people like SpaceX, of course, who have been accelerating their launch schedule to get more and more Starlink satellites into the skies to expand their internet coverage with Starlink. And they're going to be hit by this because suddenly they can only launch in this 8-hour slot every day. And that will obviously impact what orbits they can launch into and what launch windows they can meet and stuff like that. So that's going to be problematic. Now, a bit in the report here, I'm actually going to read this out and quote this because this, again, probably from an Australian and formerly British perspective, really made my head hurt. It says, during the shutdown, all federal employees deemed non-essential are furloughed. That's the NASA people, of course. So those whose job falls into the essential category are still required to work, but are not currently getting paid. They must rely on back pay once the government reopens. So for NASA, that means 15,000 people staying home and who can't comment. But in contrast, 95% of employees of the Transport Security Administration are considered accepted and have to continue to work without pay since the shutdown began on 1st of October. So not only are you... That makes my head hurt. You've got to work, but you can't earn any money, but we will give you some back pay in the future.
Yeah.
It doesn't help you buy your food.
No.
It doesn't alleviate the stress, particularly when people are doing it hard. And, you can understand that this will probably contribute to the people running air traffic control and stuff like that, not necessarily being in the best shape to do their best possible job. You've got to take account of the fact that people are human, and with the stresses and strains going on, it makes life challenging. So this shift to the rules is entirely reasonable. It's entirely well thought out. And it's a natural consequence of the problems that are going on there, but it will have an impact on the burgeoning space industry from the US, particularly with launches from Florida and California impacted by this. Basically, you can't launch unless it's the middle of the night. Now, there was a launch scheduled in the early hours of this morning, Australia time, which is the Escapade mission. It's a NASA mission to Mars. And I'm not across the politics well enough to understand quite how that mission was going to be allowed to launch, given that NASA staff are all on furlough. But I think it was probably because they got the spacecraft to the launch provider, Blue Origin, prior to the shutdown. So Blue Origin were hoping to launch that this morning before these regulations come into place, because we currently have the launch window to Mars that only comes around every 26 months or so.
Yeah.
Just opened up. But to launch to Mars at the minute, you've got to launch in the daylight hours. So there was this risk there that if that launch was scrubbed, if the launch was cancelled for some reason or postponed, weather, maintenance, security, whatever, then suddenly they run foul of this change to the regulations. Now, I've just clicked over to space.com, which is where, incidentally, the information I quoted earlier on came from. And it looks like Blue Origin delays launch of New Glenn rocket carrying NASA Mars probes, may seek exemption from the FAA in order for next try. Because this is NASA's first attempt to launch something to Mars for 5 years. If the shutdown lasts longer than the launch window is open, and an exemption is not granted, this mission will be delayed by 26 months.
And that'll be expensive too. You do not want to wait 2 years to have another crack. But
if nothing else, you have to keep all the people who have the expertise on board, keep paying for 2 years while they do other things, waiting for this to finally happen. So it's all a little bit of a car crash, unfortunately.
It sure is, yeah. And do we have any idea how long this shutdown's going to last?
It's already the longest on record, but what has struck me from the outside looking in, and I don't know if this is true on US networks and on US news stations, but in the first few days of this, it was all over the news. When I logged on the morning, I opened up BBC News website, ABC News website, and it was front page news. Now it's vanished into the background because it's old news.
Yeah.
And so it's not at the front of the news cycle. So I've not been able to get any indication of, are they close to agreeing a deal? Are they as far apart as ever? What's going on? It's already the longest one on record. And certainly there hasn't been anything in the news about a magical solution coming up. So it's a case of watch this space, but possibly a case that if you're in the US, maybe you should be kicking up a fuss about this because it's just so bizarre and unconscionable.
Yes, it is. That's probably the best way to describe it. But as I mentioned before, if this were to happen in the UK or Australia, it just wouldn't be tolerated. I don't know.
I mean, people's jobs and livelihoods are not reliant on the passing of a budget immediately in the same way there. I think that's fundamentally what it is. As soon as this happens and they don't sign the bill, the money dries up.
Well, we've got different powers in the UK and Australia. So if a government did this, the opposition would be able to go to the palace. Yeah. They'd be able to go to the palace, so the Governor-General, who's the representative of the king. And it's happened in our history before. They can just turn around and sack the government.
Yeah.
And
force an election.
Exactly. That happened in 1977, was it? Yeah. It was a while back, but it could. It's a different constitution, a different, totally different ball game in America, yes, they've got to find another way of dealing with it, I suppose. But very, very sad news indeed, and a lot of jobs on the line, and a lot of projects that are basically on hold, and we don't know when that might ease, but we'll certainly.
And it's big disruption for people as well.
Yeah, absolutely. Yeah, well,
just in their lives now.
Just putting bread and butter on the table, that's the bottom line, isn't it? And how many people are struggling with that? It's very sad. This is Space Nuts with Andrew Dunkley and Jonti Horner.
3, 2, 1.
Space Nuts.
Now, we just talked about a mission to Mars that was supposed to lift off and hasn't because of those government shutdowns. But this next story is just as weird and just as crazy and just as difficult to accept and very, very divisive. And that is the plan to send human remains to Mars.
Yes.
I would not want my human remains after I'm gone to be sent to another planet. This is my planet. This is where, even when I'm dead and gone, this is where I want to be. I don't understand this at all.
No, neither do I. And I mean, I have no religion to speak of. I have no expectations of what happens to me after I'm gone. But, I'm used to the idea that people would want their remains somewhere that those who remember them can go there and celebrate their lives, right?
That's the bottom line as far as I'm concerned.
The commute to go to Mars to pay your respects and leave a flower, This makes my head hurt in huge ways. And there's a bit of backstory to this. There's a company called Celestis in the US who seem to have this goal of putting corpses into space or putting ashes into space, whether that's your beloved pet or whether it's your beloved grandma. There is a little bit of a precedent for this. The great planetary scientist Eugene Shoemaker, who possibly most famous for discovering Comet Shoemaker-Levy 9 that hit Jupiter in the 1990s, also a big part of the history and heritage of Meteor Crater in Arizona and confirming that actually is an impact feature, was involved to some degree in the discussions of the Chicxulub impact that killed the dinosaurs. Some of his ashes went on the Lunar Prospector mission and landed on the moon. So some of his ashes were on the moon. Yeah. And that caused a little bit of a ripple. There was a bit of discontent. But a few years ago, back in 2024, this same company tried to send a package as part of one of the missions to the moon to put people's ashes on the surface of the moon. Now, this caused a lot of upset. And the reason it did is that it touched on the cultural sensitivities of different groups around the planet who have different belief systems and hold the night sky in very high regard, who have a very strong cultural connection to that. And that's true of people across the globe. And what tends to happen with these kind of companies is they don't so much, well, there is a saying that it's better to ask forgiveness than permission, but I think these companies don't even ask forgiveness after the fact. But there isn't much evidence that they attempted to contact and communicate with different people around the world to see whether this would be problematic or offensive. Now, it kicked off in early 2024 because the Navajo Nation in the US hold the moon as an incredibly sacred place in the sky. And to them, putting human remains on the moon is testament to sacrilege. It's desecration. It is incredibly offensive and hurtful to them. So they came out very strongly against this. I think they put protests in. I think they were even looking at court cases. The CEO of Celestis, in response to that, was quoted, in my eyes, I hear this, I read this as being incredibly dismissive and incredibly lacking in cultural competency and awareness. He just came out and said, we're aware of the concerns expressed by Mr. Negron, who's the leader of the Navajo Nation who was raising it. We're aware of his concerns, but we don't find them substantive. We reject the assertion that our memorial spaceflight mission desecrates the moon. Just as permanent memorials for deceased are present all over planet Earth and not considered desecration, our memorial on the moon is handled with care and reverence. It's a permanent monument that does not intentionally eject flight capsules to the moon. It's a touching and fitting celebration, the exact opposite of desecration. Which seems to me like he's not at all interested in the views of people from other cultures and with other belief systems. And I found that, to be honest, a very offensively worded statement. Given that I know of the problems we have here in Australia with dealing with the traditional owners of the land here, there's a lot of problems there. There's ongoing issues like sacred sites getting blown up by mining companies, things like this. This is not unprecedented.
Yeah.
But there's this ongoing struggle to gain awareness of the best way to manage things where different cultures have differing opinions and to get the best result for everybody. And we've seen over the years really good examples of where this has been managed well, and the Square Kilometre Array in Western Australia is held up as like the shining light of how to manage these kind of frictions and bring people on board and do it well. There have been examples that are equally illuminating at the opposite end of the spectrum. The 30-meter telescope on Hawaii is a good example of where it's been managed badly. And I think this from Celestis is much the same thing. So that's the background. Here's a company that wants to go ahead and put wealthy people's remains on celestial bodies, and they don't really care what anybody else thinks, because if we're doing it, it can't be desecration, right?
Yeah.
Now, their latest plan is to they are opening up reservations. You've got to pay 10% up front, which is a good way of making a bit of money, to send your ashes to Mars. They've got their Mars 300 project. And that aims to have something that flies as a secondary payload on one of the future Mars missions. They've not identified a mission they're going to bolt their capsule onto yet, but the goal is to launch this in 2030 as their first burying people on Mars attempt. Now, they're charging a huge amount for that. I don't know what a normal funeral will cost. I'm very fortunate that I've never had to organize one myself. But they are charging people $24,995 US for the privilege of having some of their ashes put in a capsule and sent to Mars. 10% of that has to be up front. Now, there's a lot of aspects to this that are weird beyond the cultural side of it, which, I find very distasteful. It's a bit different if we've had those conversations and people are on board and you've confirmed that there is no culture on Earth that would find Mars sacred and find this inappropriate. That doesn't appear to be the case. But even ignoring that, one of the big costs for sending missions to Mars and to Europa and to all these other places that we think could be potentially habitable is something called planetary protection. It's basically the fact that if you're going to anywhere where there is even a remote possibility that human or Earth-based life could survive in those conditions, even if it's a very remote possibility, then there is an extra burden of sterilization to reduce, minimize, or even try to absolutely prevent any possibility of contamination of that environment. Now, it's very important for Mars and Europa and everywhere. partially because we don't know if there's life there, but also because if we want to find out if there is life there, the last thing you want to do is get a false positive because you've detected some Earth bacteria that have been spilled there.
Yes.
Now, I think the planetary protection thing personally is a little bit overblown, purely because life from Earth will have been scattered across the solar system repeatedly over the years through meteorite impacts on Earth, knocking bits of the Earth off into space, and things transiting between the planets. That's a process called panspermia, which sounds utterly science fiction. Sounds like it couldn't work, but every experiment anybody does on Earth kind of shows that that actually would work. And if it would work over 4 billion years of the solar system, the Earth will have sneezed repeatedly on the other planets and the moons in the solar system and basically inoculated them with terrestrial life. Yeah. So it's already there if it is there. But the other thing is, if we take life to Mars and there is life there, the life that's on Mars is adapted to those conditions. Our life will not be. So I think there's a little bit more spent on planetary protection than is perhaps needed, but at the same time, it's better to be safe than sorry, so I understand why. But it seems to fly in the face of planetary protection to just send human ashes to Mars. I mean, that feels like a pretty high risk with no reward. I can understand if you're sending a scientific mission, you've got the instruments that get sterilized. There is a reason to have those instruments there, and then you weigh the reward and the cost effectively. I don't see any reason other than vanity for us to drop human ashes on Mars. I don't see any benefit to humanity long term or to science. So I don't see why you would do something like that that brings with it the incredible risk of something going wrong with those ashes actually being scattered on the surface rather than being contained in a container. It just seems a bit like the reflect orbital stuff we talked about the other week.
I was about to bring that up, yeah.
Yeah, it's one of these things where, what's that famous quote? It's like people spent so much time figuring out how to do something that they never asked whether they should. It feels like one of those.
It does, doesn't it? Very much so. Yeah, I must admit it's a big head scratcher, and I just don't see any logic in this whatsoever. And yet, I'm sure they will get people signing up.
They will do. You know? And my criticism here is not for the people who sign up. It's a bit like the many different things you see online where you can name a star after somebody. And of course, that is not an official naming of the star. You might get a certificate with the name on, but it's not an official astronomical name. It won't appear in any of our catalogues. But even though I will criticize very vocally the companies that run those kind of businesses, I have strong opinions there. I'll never criticize someone for signing up to do it, because when you're grieving and you want to do something to commemorate someone, or when you want to do something nice for someone to celebrate them, it sounds like such a lovely idea. And this is a bit like that. I'm not going to criticize the people who want to send their puppy's ashes to space or who want to send Granny's ashes to space. If you think that's a lovely way to commemorate them and something special, more power to you. Not at all offended by that. My problem is with the people who are capitalizing on people's grief and riding roughshod over the cultural sensitivities of different people around the planet because they can, because there's nothing there to stop them. And I should say, I'm trying to be as sensitive about this as I can do. I, quite happily admit that I'm a white British male, Australian male now, I've got the passport. These cultural issues don't directly impact me. But I work with people who spend a lot of their time looking into this, who have, for example, spent a lot of effort working with the traditional owners here in Australia to learn more from their knowledge and to work with them and repair the damage that's been done in the past. And there are people actively trying to make the world a better place. And things like this just seem to ride roughshod over that.
Yes, that is exactly what it sounds like, for sure. We'll certainly hear more about this down the track. Hopefully common sense will prevail, but I suspect not. This is Space Nuts with Andrew Dunkley and Jonti Horner.
0G, and I feel fine.
Space Nuts.
This next story is a little bit more positive, or is it? Yeah, I think it is. This is based on some evidence that's been dug up, literally, in Western Australia, and it focuses on new evidence about the formation of the moon. I do like this story, I must say.
It's a fabulous one. It's good to get to something cheerful. Now that I've got all my angst about the football out by ranting about stupidity, we can get onto some good science and some good fun stuff. So yeah, sorry everybody for the cheerful episode so far, but now we're getting onto happier news. This is a really fun story, and it's born from Western Australia. Western Australia is home to some of the very oldest rocks that survive on the surface of the Earth.
Yeah.
I've mentioned before the oldest fossils on Earth that are widely accepted are found out in the Pilbara region, date back about 3,500 million years. This is actually rocks that are a bit older than that. This is feldspar crystals in some old volcanic type rocks called magmatic anorthosite. Now, I'm not a geologist. I can't tell you exactly what that is, but these are rocks that on the surface of the Earth are very, very rare. Feldspar is one of these minerals I'm led to understand that on the surface of the Earth it's very rare, but you find most of the Earth's feldspar, those kind of minerals that would form it, deep in the Earth's mantle. So we have very little of this on the Earth's surface. By contrast, there's a hell of a lot of feldspar on the moon. I think particularly on the Mare there, on the lunar seas. Now, people like to study the oldest rocks on the Earth because it gives us a window into the planet's youth, into things like when did the continents first start to form? How did that process happen? You know, how did we get plate tectonics getting started on our young magmatic Earth? How did all that happen? We've also got this whole thing, which has been a puzzle for a very long time, about the origin of the moon. So you've got the Earth and moon flying through space together. The moon is sufficiently close and tightly held by the Earth, and in the past it was even closer and more tightly held, that it can't be an object that was gravitationally captured from elsewhere. That would be incredibly difficult to happen. From an orbital mechanics point of view, which is my wheelhouse, that's not something you could expect. So the moon has to have formed with the Earth, which means that you'd expect them to look the same, have the same composition. But the moon is depleted in the heavy elements that are common near the Earth's core, and it's enriched in the material that you'd find in the Earth's mantle and the Earth's crust. But the isotopic abundances, the things that give you a very fine-tuned position on where in the protoplanetary disk the thing formed, the moon and the Earth are essentially identical. So the bulk composition is different, but the makeup of the different elements is the same. So all these pieces of evidence point to what is known as the moon-forming impact theory, which has become really widely established, a giant impact theory. The idea that the Earth formed all in its lonesome, poor Earth, all alone, and then it made a friend. It had a collision with an object about the size of Mars, which people commonly call Theia. And this collision was pretty catastrophic. Certainly would have been life-ending for any life that had already begun to develop on the Earth, because it tore the Earth asunder. It shattered the Earth and spattered the mantle and the crust, particularly into the space around the Earth. The impact wasn't energetic enough to totally disrupt our planet, so the Earth's core stayed relatively intact. That's part of the story. So what happened then was all this material that had been splashed out, which was primarily the mantle and the crust, the lighter material. A lot of it agglomerated in orbit around the Earth to form the moon at a distance just a little bit further out than the Roche limit. So the Roche limit, as a reminder, is the closest distance you can take a solid object to a planet before that planet's gravity pulls it apart due to tidal forces.
Yep.
Moon formed a little bit further out than that, initially going around the Earth every few hours while the Earth was spinning really quickly. And over billions of years, the tidal interaction between the moon and the Earth has caused the moon to drift away, exchanging angular momentum with the surface of the Earth with the Earth's rotation, which means our rotation has slowed. Until today, we get to a 23 hours, 56 minutes and 4 seconds rotation for the Earth, technically, with the distant stars, and the moon going round, roughly once a month. And it's still edging away a little bit. We can measure that, incidentally, with the retroreflectors the Apollo astronauts dropped on the surface of the moon, which is yet more evidence that the moon landings definitely happened. Not that I think anybody listening to this podcast will question that they're not in that particular conspiracy camp.
Although, if I can just jump in there was a post on Facebook I read this morning, and it posed the question, something you were told at school that proved to be wrong, and someone's put the answer, moon landing.
Yes.
Yeah.
Now, I mean, I've seen all sorts of memes about that one. One that always sticks to my mind is that, of course, the moon landing was faked, but they got Stanley Kubrick to do it, and he was such a stickler for detail that he wanted to film everything on location. But anyway, we've got this very well-established story of the origin of the Earth-Moon system and how it all worked. And all the pieces seem to fit. Yeah, there's a little bit of tuning around the edges going on. Whenever we get new information, we refine the story. We get a better model of what's happening. you sometimes get additional parts of the story, like trying to explain why the side of the moon facing the Earth and the side of the moon facing away from the Earth are so different. That's part of the ongoing narrative of what happened in the impact and what happened afterwards. These new results, though, are really nice because they are essentially an additional piece of supporting evidence for this whole big splat type theory. They're looking at these feldspar crystals in these magmatic anorthosite rocks. These are rocks that are so common on the moon that the Apollo astronauts brought some back. So yet again, strike one for we've actually been there. On Earth, they're very, very scarce. But what's really nice is that the rocks that they've found in WA with these crystals in, they've been able to analyze the chemistry of them, and they're essentially identical to the feldspar found on the moon.
Wow.
Really kind of spot on, a really good match. And that's just a really additional strong piece of evidence that we're following the right narrative, that we're on the right lines, that the moon and the Earth were formed in a giant collision. We've got evidence, incidentally, that giant collisions were very much the norm in the final parts of planet formation, and there are arguments for every one of the 8 planets to suggest that they may have fallen victim to at least one, possibly more giant collisions. Not all of those will necessarily be borne out, but they were just the norm rather than the exception. And the Earth-Moon system was a prime example. Now, Earth-Moon 1 was probably the first giant collision that was really scientifically supported, although, people have been suggesting a giant collision for Uranus to explain its tipped-overness for a very long time. Just a natural part of the planet formation process.
It was probably Planet 9 that did that.
Well, that's part of where the Planet 9 story comes in as well, because it is likely that there were planet mass objects or bigger that formed in the outer solar system that were scattered outwards. I had a very dear friend of mine and good collaborator visiting for the last couple of weeks from Japan. That's Professor Patrick Sophia-Likafka. And Patrick was telling us about his latest work, which is getting submitted to journals soon, looking at the structure of the Trans-Neptunian region, so the Edgeworth-Kuiper belt, the scattered disk, the detached objects, all these things that are pristine pieces of evidence for the early formation of the solar system and how the planets moved and migrated. And what he's finding that's really interesting is that Neptune migrating outwards, the models we currently have do a really good job of explaining the solar system inside about 50 AU. So the Edgeworth-Kuiper belt, the scattered disk, but they do not fit and do not match at all the objects that are further out if you do not have additional planets further out. So it's yet more of this building the narrative, a bit like the moon forming impact. We just keep finding more and more evidence that takes further observation. Now, that's going to be interesting. Obviously, once Patrick's work comes out, I'd happily hop back on and fill you all in on it, because it is really cool work. And I think that kind of stuff deserves more of a profile. I will be a co-author on those papers, incidentally, so I'm very excited about that.
Very good.
Coming back to this work, though, looking at these feldspar crystals.
Yes.
There's another point that's just made as a byline in this, and again, not being a geologist, I'm not fully across the why of this, but another of the results that comes out of this study of the chemistry of the feldspars and where they found them and these, the magmatic anorthosite. And a side result that's come out of this suggests that we may have to slightly revisit our clock and our understanding of when the continents themselves began to form, when you first started getting continent formation, which I think, and again, please write in if I'm summarizing this badly, but I think it's due to the nature of the rocks that are extruded through the eruptions from the mantle and the volcanism that goes on as the planet cools, as you get different chemistry going on. You get a fundamental change in the nature of material that is being extruded, and eventually you get to a point when you can form continental crusts, eventually, and the nuclei of continents. Apologies if that's badly explained, but like I say, it's not really my wheelhouse there. But the side result of this work is suggesting that that continent construction process, the formation of the first continents, didn't start until about 3.5 billion years ago. So that's about 1 billion years after the Earth formed, probably about 1 billion years after the moon forming impact, which is putting a clock on how long it took the Earth to cool down enough to start that process. But what I found really interesting, and it wasn't really mentioned in the article, is tied back to what I said right at the start of this bit. You have this idea, you have this evidence from the Pilbara region that the oldest fossils on the Earth are 3.5 billion years old. You're now getting suggestions here that the start of continent formation on the Earth happened 3.5 billion years ago. Makes you wonder whether there's correlation there, whether there's causation there. In other words, life became established well enough to give us fossils at the earliest possible opportunity it had. Now, that's very speculative at this point, but it's an important datum when it comes to the search for life elsewhere, because the faster life got started on Earth once the opportunity was there, the easier that suggested is for life to get started, and therefore the more confident we can be when we start looking for life elsewhere, when we do that. So that's a nice little angle, I think, to finish on with this one, but it's a very cool story and well worth following up for people who, particularly those who are into the geology.
Yes, and if you'd like to read about it, space.com, or you can go to the University of Western Australia website. There's a really good article on that website about the discoveries that have been made. One final story, Jonti, and Fred and I have sort of talked about this on and off for a very long time, and that is, what's going to happen to the universe? Is it going to continue to expand at an accelerating rate and ultimately rip? When I was growing up, the opposite was going to happen. There was going to be the big crush, or the big crunch, or the Gnab Gib, which is the opposite to Big Bang. Now, the current thinking is that it was accelerating outward and getting faster and faster. Now we've got evidence that's starting to suggest that the original theory might actually be where we're headed. This one is, it's a bit of a tug of war between two potential theories.
It is, and it's very much a great illustration of how science works at the frontier. It's very much a journey of discovery that is a really complex interplay of observation and theory. Astronomy is a bit different to the other sciences in that in physics and chemistry and biology, you can do experiments in the lab. Whereas in astronomy, everything's so far away, you have to observe. So we're a bit more Sherlock Holmes than an experimentalist is. It's a detective story gathering clues. Now, there was a massive paradigm shift, massive revolution back in the late 1990s, which led to the awarding of the Nobel Prize that went to a team including Brian Schmidt, who is a, famous researcher in Australian circles, was briefly the VC of the Australian National University. It seems to be an all-round good guy, but apparently doesn't make the best wine on the planet, is what I've been lightly told. And sorry, Brian, if you're listening, that's just total hearsay, but there you go. But he's an absolutely stand-up guy, and got the Nobel Prize, which, doesn't happen to everybody.
No.
And that was all around observations of distant supernovae, right at the outer edge of the universe. Now, these supernova are one of the things that astronomers use as a standard candle. So this is how we build the distance ladder to the distant universe. We have a number of different techniques that allow you to measure distance that work at different scales. So if you want to get the distance to the nearest stars, you use parallax, which is Earth goes around the sun, we observe from two sides of the Earth, and we see the star move against the background. And the bigger the motion, the closer the star is. And you can do this yourself. You can hold a finger up in front of your face, close one eye and look where the finger is against the background, then open the other eye and look at where it is. And by the shift, you get an idea of how far away it is. And I think, this is how cricketers and other sports catch balls. Your brain is naturally doing this kind of triangulation. Hopefully that won't be working that well for the Aussies in the coming Ashes match that's going to start fairly soon. They're all getting a little bit old and creaky, so I can speak from personal experience, depth perception is challenging them. But that's the parallax method, and that gives you the distance to the nearest stars. But eventually stars are far enough away that wobbling is not measurable anymore. So we can't measure their distance in that way. But fortunately, there's a class of stars that are fairly rare, but fairly luminous, called Cepheid variables. And this was great work done, I think, by Henrietta Leavitt back in the early 1900s, who identified, by looking at the Large Magellanic Cloud, that all the Cepheid variables in the Large Magellanic Cloud, which are all effectively the same distance away, the brighter ones oscillated with a different period than the slower ones, and all the ones of the same brightness oscillated with the same period. So what that tells you is if you can measure the period that these variable stars wibble, you can infer their total brightness, you can measure how bright they are in the sky, and therefore work out the distance. So that gives you a standard candle. The most distant leg of the standard candles are supernova 1A, which are stars reaching the end of their life and going boom. And there's always been this suggestion that all supernova 1A reach about the same maximum brightness. So if you can measure how bright a supernova appears to you, you can measure its distance. And it gives you that standard candle at immense cosmological distances. The work done in the late 1990s was looking at the most distant supernova ever seen to put a distance on those galaxies and then measuring the redshift of those galaxies to find out how fast they're moving away from us. In other words, to map how the expansion of the universe changes with distance. And what they found was hugely surprising to everyone. Their results indicated that rather than the expansion of the universe slowing down as gravity starts to pull back, the expansion of the universe has actually been accelerating and getting quicker and quicker, which is not what you'd expect if you think gravity is the thing that's winning. And this was the discovery that led to the birth of the idea of dark energy, or, the discovery of dark energy, which is considered to be 68% of everything in the universe. It's a really big contributor. All of the evidence for that came from this expansion of the universe accelerating and getting quicker and quicker as time goes on. Now, it's just a couple of years ago that there were some new results that came in that slightly throttled back on that. They did a little bit of a recalibration of that distant supernova data, apparently using baryonic acoustic oscillation measurements. I'm not a cosmologist. I have no clue what that is, to be honest, but that's how they did this. And that led to the conclusion that, yes, the acceleration is there, but it's not as pronounced as we think, and it should stop at some point, and then the universe should start decelerating, should start slowing down again. Because it turned out that they corrected for the data that had been made in the original discovery. They got essentially better observations, better data that allowed them to refine things. So that suggested that instead of the acceleration increasing, the acceleration was starting to ramp down and would eventually start decelerating. So that started throwing things into doubt. The new results have brought in an additional thing where they are now realizing that the brightness of the supernova 1A standard candles may not be as constant as people think. That there's actually an age-brightness relation where supernova in the distant universe and supernova close by will reach different maximum brightnesses. And that means you then have to recalibrate the distances to the things in the very distant universe again, which changes the lens on whether they are accelerating more slowly or more quickly than expected, and therefore changes the outcome of whether the expansion of the universe is accelerating or slowing down. Now, it's stressed in this that these new results still have to be confirmed, in that there needs to be more data obtained to support what their conclusions are. But if what they've discovered here is correct, the team involved are arguing that this could be the biggest paradigm shift in this area for 27 years, since that discovery of dark energy, since the discovery of the accelerating expansion of the universe. And they're even suggesting that the universe's expansion may already be decelerating. So it may no longer be accelerating. There are suggestions, therefore, that dark energy is weakening, that the universe is going to slow down and eventually turn around. I should stress that this is so far out of my wheelhouse that that's about the level of the depth that I can go into it. If you want to do a deep dive on this, we're very fortunate up here in Queensland to have one of the world's leading cosmologists at the University of Queensland, Professor Tamara Davis, who now has the Order of Australia Medal, OAM. She's a fabulous science communicator, and she is one of the world's real leading experts. She's one of the leading lights in the dark energy survey. So if you were ever in a position to get somebody on as a guest to talk through all this, because I know the audience loves it, she would be an ideal person if she was free. Tam's brilliant. But in terms of building on this, I talk a lot about Vera Rubin Observatory coming online because I'm excited about the solar system side of it. It's going to find more of everything. Part of finding more of everything, though, is that Vera Rubin will discover and observe somewhat more than 20,000 new supernovae in very distant galaxies over the next 5 years, allowing more precise age and distance measurements that have ever been made before, which should actually allow people to work out whether what this team is finding holds water, whether the original ideas were right, what the story is. So I think this is a very moving story, and we've certainly not reached the end of the debate over the exact nature of the expansion of the universe and, by extension, dark energy. But this is pointing at the fact that there is more to learn. And I guess this must be how people feel when you start getting close to those scientific paradigm shifts that are huge, like when relativity and quantum mechanics were developed in the early 1900s. For a couple of decades before then, results had not been quite what you expected, and there was this growing feeling that there was something more to come, but they weren't quite there yet. And this has that feel that the next big discovery is just around the line, and we're starting to get stronger and stronger evidence that there's something really awesome to learn in the next few years.
Yeah.
It's very, very exciting, but also very much out of my comfort zone.
Yes, but it's also one of those topics that people latch onto and we get so many questions about. And I think we actually got a question of this ilk for our next episode, which is the Q&A episode. So we'll be tackling that again. But yeah, fascinating story. And if you'd like to read all about it, you can do that by looking up the paper on the monthly notices of the Royal Astronomical Society. And I think it's titled Strong Progenitor Age Bias in Supernova Cosmology. There you are. Hope you wrote that down. That's it. Thank you, Jonti. Entertaining and informative as always.
It's an absolute pleasure. Thank you for having me. And sorry for the rantiness. It's been a ranty week, so I feel that we should have a happy week at some point.
We'll get around to it. Jonti Horner, Professor of Astrophysics at the University of Southern Queensland, joining us this week while Fred gallivants around Edinburgh. And don't forget of it. Hugh in the studio, we have to thank him. He couldn't be with us today. He got himself 300th in the queue to have his mortal remains sent to Mars. And he's just waiting for his chance to pay the deposit. Who's going to tell him? And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Until then, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.